Hello everyone. In this video, I will go over an example of surface integral of a vector field. So given a vector field f, we denote a surface integral by a double integral sign over s of the dot product of the vector field and the vector surface element, where n is the unit normal vector to the surface element and ds is the length of the surface of the vector surface element. So this is equal to the double integral over region R of the dot product of f evaluated at a parametric representation, and n is the normal vector to the surface element while we're integrating over the whole surface. So n is equal to the cross product of the partial derivative of the parametric representation with respect to u and with respect to v, and R is the domain of uv to generate the whole surface S. So we go over an example when f is equal to 6z minus 4y and s is the portion of the plane 2x plus 3y plus 6z is equal 12 in the first octant, and we need to evaluate this surface integral. So we described, so the surface is the portion of the plane in the first octant, which will be this surface here, and D will be the triangle under the surface, which is bounded by the x-axis, the y-axis, and the line y equals minus 2 over 3x plus 4. So we need this for the double integral. So for example, if you fix a point x here, y will vary from 0 up to this point over here in y. So we need to know this line to do the integration. So we take the parametric representation. Rxy will be xy, and z we will replace it by the from the formula of the plane. So where xy is in the domain D that I showed you before. So this is the plane, the triangle D. So next we calculate the partial derivative of r with respect to x and derivative of r with respect, the partial derivative of r with respect to y, and then we evaluate the normal vector by evaluating this determinant. We get 1 over 3, 1 over 2, 1, and then we evaluate f at the parametric representation. We get minus 2x minus 3y plus 12 minus 4y, and we substitute everything on the first equality 1. We get the double integral of the domain, and this is f evaluated at the parametric representation, and with the dot product with the normal vector we get the double integral over the domain D, or the triangle D, which is equal to minus 3 times x plus 2 dx dy. So now we want to calculate this double integral over the triangle D. We can fix x between 0 and 6, and we integrate y from 0 to minus 2 over 3x plus 4 dy, and then we integrate with respect to dx. So we get the integral from 0 to 6 of this expression. The expression here, we get it from here times minus 2 over 3x plus 2. So this will be the integral of this would be 4 over 27 x cubed minus 2x squared plus 8x from 0 to 6, and this will give us 8. And this is the end of example. Thank you, folks.